Hello, my name is Cyril Chan, and this is a video demonstration on the fourth laboratory activity, debugging and troubleshooting. So first, we open up LabVIEW. Oh my, there. Next is we open our existing file, which is our project file. We wait for it to load. There, it's opening. And here we have our project, which contains two BI files. So the first file that we'll be looking into would be the broken button. We press Ctrl T to display both our front panel and block diagram. And so first thing we'll notice here on our block diagram, so we'll have that enlarged. First thing that we'll be noticing here would be this broken run button, which has already been mentioned right here on its title, broken run button.py. So that broken run button means that something or some things are wrong with this block diagram. We can check what are the things that are wrong or bugs in this block diagram are by clicking our broken run button. As you see, it displays list errors. So here we have our error list window, which here on the top it lists the items with errors. In the second box, we have the multiple things that are wrong with our block diagram. And on the third window, it describes in more detail what is wrong with each of these errors. So to look at what error these items refer to, you can just double click it or show error, and right there we have an error. Again, when we show error, as we see here, this one of the inputs is not connected, which is also explained here. Divide contains unwired or bad terminal. And in this case, it's just unwired. So the fix would be just to connect this to the related input or constant in this case. Next is right here. You have connected two terminals of different types. So when we check on it, and here we have it right here. So it says that our source is Boolean and our sync is a string. So the thing to do here is to we'll replace this component. We'll delete that. Oh my. Yep. Just as planned. And we'll remove this connection. And we'll manually add an indicator. And now our source and sink are of the same type, Boolean and Boolean. Now for the last error, you have connected an input of add to a control, change the control to an indicator. So, wow, it showed us how to fix the error. Now we show the error. So this one, this type of component, it's mentioned to be a control, and that we have to change it to an indicator. Now we have it. It's now fixed. Now we have our error list here displaying no VIs or virtual instruments with errors. We can close that. Control T again to display both. And now, oh my, we can run. Oh, it runs properly. That was the first part of the laboratory activity, debugging. So now we close these windows. We don't have to save them. Now for part 2 of the experiment, dealing with runtime errors. Now we open up incorrect behavior right here. Control T again to display both. As we see here in our block diagram, as compared to the first one, our run button here is fixed. So now we wonder what's actually wrong with this. So let's see when we run it. Oh, it runs just fine. But the deal with runtime errors is it's more like the error is found on how it works. So it means that it does work, but it does not work as intended. So for example, here we have our degrees Celsius here, and we have our degrees Fahrenheit. So here we can check whether its conversion here is correct. So let's open up a calculator. Now we have here, very conveniently, the formula from degrees Celsius to degrees Fahrenheit. So our current temperature, 49.4819. So we have here times 9 divided by 5 and plus 32. And oh wow, it actually has a huge difference right there. Now the next question is, how do you find what's wrong with it? So we actually have a few different tools which can help us identify the problem or the runtime error. So some of these are execution highlighting, probing, using breakpoints or single stepping. And we'll be going through the 4 of those in this experiment. So execution highlighting, we've been introduced with execution highlighting on our previous experiment, which is, it's actually just this light bulb here, which displays the flow of data in these pointers within the block diagram. sort of like similar in Python that we run it line by line. It's similar to that. So here we click on single stepping, and there. It's another single step. Next, next. Now we have our data flow. And next, 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 and there. It sort of indicates that it's done running. So that was single stepping. It literally is single stepping each component or each line of the block diagram. So the last tool that we'll be looking into is breakpoint. What the breakpoint is sort of uh, hmm, a stop sign perhaps. Yes. So basically, a breakpoint is where the uh, block diagram stops running. So for example, we set up our breakpoint right here. Set breakpoint right there. So now we have our breakpoint here on our add DI. So when we run our code, it stops there. It won't run any further because our breakpoint is right here. It's sort of like it pauses or stops right there. So there would be some instances wherein you want to see what happens to the code until up to a point. You can use a breakpoint there. So we can, after using a breakpoint, we can remove it by here. We can clear a breakpoint. Just now we saw a clear breakpoint and what was that? There, disable breakpoint. What disable breakpoint does is it doesn't really take away the breakpoint function placed into the component, but rather it's sort of just temporarily sort of a turn off switch in which you can just turn it off, turn it on again by enabling it. So now to fix the runtime error, it actually looks obvious right here. When we see our formula right here, we multiply our value by 9 and then divide it by 5. But what happens in our block diagram here is we multiply it by 5 and divide it by 9. So this one is just a simple fix. Now please cooperate. Right there. And again. Now we position them. And then we connect our components just like so. And we see, just turn it off for quicker execution. Let's check again our calculator. $49.4819. Yep. Now it's times 9 divided by 5 plus 32. Now we have 1 to 1, 1 to 1, 0.06742 067. And there we fixed our runtime error. So again, our runtime errors don't really cause any error on the running, but rather it causes the run to have an incorrect output. So we close it again. That's everything. And that was part 2 of the fourth laboratory activity, and also the last part of the fourth laboratory activity. And thank you for watching.